Alright, so this section is the beginning of chapter 12. This is on trigonometry, and that word actually comes from, I think, a Greek word, trig meaning triangle, tri meaning three, gon meaning side, so a three-sided figure is a trigon or a triangle, and then metry meaning measure. Basically means the science or the practice of measuring triangles. It's used for a lot of interesting things. It was used to, for example, find the heights of mountains before we had GPS systems, that kind of thing. So in this section, we'll be dealing with a couple basic things we want to do. First of all, learn how to find the 6 different trigonometry values, and those are sine, cosine, tangent, and then their opposites or their reciprocals, which are cosecant, secant, and cotangent. Those are abbreviated right there. Then we want to know how to go back and forth between, if they give you angles, how do you find missing side lengths? And then actually number 3 should say find angles given side lengths. That's a typo there. And then finally, solving word problems using trig would be our last goal. Okay, so first of all, trigonometry deals, or this particular chapter deals with trigonometry for right triangles. A right triangle means a triangle just like this one that has a 90-degree or a right angle. And the symbol for missing angles usually is this symbol right here. It's called theta. It's a Greek letter. Theta is to trigonometry what x is to algebra. In terms of, if we look at theta right here, this side that is directly opposite to it, obviously would be called the opposite side or the opposite leg. Right triangle has 2 legs, and then it has the longer side, which I'll highlight in red right here. This longer side is called the hypotenuse. So the side that's completely opposite to it is the opposite side. The side that's right next to it, which is this green one, word for right next to is adjacent. So the side that's right next to the opposite side, which is this yellow one right here. The way that you know it's opposite is no part of this touches a side that has theta. This yellow and this red do touch where theta goes, but the opposite side does not. Okay, and then here are the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. So there's a way to remember this. The acronym is SOHCAHTOA, and sine means the opposite side over the hypotenuse, cosine means adjacent over the hypotenuse, and tangent means opposite over adjacent. And then these other 3 right here, which might be new to some people, these are just the reverse. So, for example, sine, if you were to flip the opposite in hypotenuse, you would get hypotenuse over opposite, and that's called cosecant. Cosine, if you were to reverse adjacent hypotenuse, you would get this one over here. The name for that one is secant. So for example, if the cosine of an angle was 3 over 5, its secant would be 5 over 3. You just, basically they're reciprocals, you reverse them. And then similarly, tangent, opposite over adjacent, if you flip those, you would get cotangent. Tangent and cotangent is easy to remember based on the names, but those are opposites. The way that I remember the other ones is that sine and cosine, sine starts with S, cosine starts with C. If you reverse sine, if you reverse the S, you have the function that has a C in it, you have cosecant. Similarly, if you reverse the C in cosine, you have the one that has an S, secant. So those tend to go together. Hopefully that didn't confuse anyone, but if not, there's only 6 to remember. Alright, so let's find these 6 values for angle theta right here. And these, we can basically read these off of the graph. We actually use a different color here so we can see that better. So we want sine, we want cosine, and then finally we want tangent as well. And then the ones that go together with it. So obviously once you find sine and cosine, it's easy to find, sine, cosine, tangent, it's easy to find the reciprocals. Remember, secant goes with cosine, it's the reciprocal of that, and cosecant goes with tangent, it's the reciprocal of that. So let's find each of these. So first of all, sine, if we remember this acronym, sine is opposite over hypotenuse. It's SOHCAHTOA, so sine is opposite over hypotenuse. Here's theta. Opposite to theta is 8, and the hypotenuse of that triangle is 17. So the sine would be 8 over 17. Cosecant is just the reciprocal of that, so 17 over 8 would be cosecant. SOHCAHTOA, so ka is cosine. SOHCAHTOA, that means adjacent over hypotenuse. So if we look again at theta, adjacent to theta is this one, 15 is adjacent to it, and 17 is the hypotenuse. So cosine is adjacent over hypotenuse, or 15 over 17. And the reciprocal of that would be secant, that's 17 over 15. Okay, the last one would be tangent, which is opposite. So here's opposite over adjacent. There's, sorry, it's not adjacent. Adjacent is right there, 15. So 8 over 15 would be opposite over adjacent, and cotangent is the reciprocal of that, that's 15 over 8. So we just found all 6 trig functions. All right, and we already said basically that the reciprocals of each of these sine, for example, if sine were equal to 3 over 5, the reciprocal of that, so 1 over 3 over 5 dividing by 3 over 5 is like multiplying by the reciprocal, which is 5 over 3. And that's equal to cosecant. So these are related by being reciprocals. The cosecant is just the flip of sine. The same is true for secant and cosine, and for cotan and tan. Okay, so this is a similar problem, slight difference now. They're only giving us 2 sides, so we need to find the other 6 functions. So let's find cosine. Let's find, if we know cosine, we'll also be able to find secant. And then if we also want to know tangent, and if we know tangent, we can easily find cotangent as well. And then I guess we'll also need to know, they gave us sine, so we'll need to know cosecant, which is the one that goes with sine. We can find that right away. Cosecant is the reciprocal of 5 over 8, so that's 8 over 5. So there's one of them. Let's find cosine now. Remember, this is a right triangle, and if you have 2 sides in a right triangle, you can find a third side by using the Pythagorean theorem. The Pythagorean theorem says that if you take this number squared plus that number squared, you would end up with the hypotenuse squared, that's the a squared plus b squared equals c squared. That's what that means. So let's solve this. 5 squared is 25, and remember the 8 came from this hypotenuse. That's why we're squaring it. 8 squared is 64. You could solve that by subtracting 25 from both sides. We would get 64 minus 25 is 39. And then if we square root both sides, we would get a equals the square root of 39. It doesn't make sense to change that into a decimal for 2 reasons. So actually, first of all, we wouldn't put a plus or minus in front of it like we normally do for algebra equations, because a minus wouldn't make sense. You can't have a negative side length in a triangle. And then we don't want to change root 39 into decimal, because they're asking for an exact value. And if you took the square root of 39, you get a decimal non-exact value. So let's find cosine of b. Angle b is right here. Cosine is adjacent, which is that one, over hypotenuse, which is that one. So square root of 39 over 8, and that is cosine. Secant is the reciprocal of that. So secant would just be that flipped over. But here's the thing, we don't want to leave the radical 39 on the bottom, so we have to rationalize that. And this comes out to be 8 radical 39 over, when you multiply those two together, rad 39 times rad 39, you just get 39. So that's actually equivalent to 8 over radical 39. And then the last one would be tangent. Tangent is opposite over adjacent. So here is opposite, and there is adjacent. So that's going to be 5 over radical 39. And again, if we rationalize that right there, we would end up with 5 radical 39 over 39. That's tangent. And at cotan, we can just flip this over. That way we don't have to rationalize it again. So that's going to be radical 39 over 5. Okay, there are 3 kind of special angles in a triangle that I would say should really be memorized. And those are 30 degree, 45 degree, and 60 degree angles. Those come from special triangles, 30, 60, 90. So I'll show you where at least the 30, 60, 90 comes from. Let's say you have, it's kind of like a small proof here. Let's say you have an equilateral triangle. Equilateral means all sides are equal. And since a triangle has 180 degrees, if you evenly divide that into the 3 angles, you would have them all being 60. Let's say we don't know those sides, so let's call them all 2x. And you'll see why we're doing 2x instead of x in a sec. But we don't know the sides. Okay, now let's suppose that I carve this kind of halfway down the middle, just like that. Well, if I cut that 60 in half, it becomes a 30. This angle is a 90, and then this side at the bottom that used to be 2x, it now gets split into 2 halves. Let me redraw this triangle right here, this blue one, like this. I'm going to redraw it so we have a 90, that's 30. That's this 30 right here, by the way, and then this is 60. This side is x, this side is 2x. How do we find this missing side here, this other leg? We could do that squared equals this thing squared plus, and then this one we don't know, so that's squared. We subtract this from both sides. This thing, by the way, is the same as 4x squared. So if we subtract x squared, we would get 3x squared is equal to question mark squared. Let's square root both sides. And if you square root 3x squared, you would get square root 3 times x. That's what this side is right here. So how does that help us know the special angles? Well, here's an example. Let's take the sine of 30 degrees. 30 degrees is right here. Sine is opposite over hypotenuse, so x over 2x, and the x's cancel, and you get 1/2. Let's take the cosine of 30 degrees. Cosine is adjacent, which is this one over hypotenuse, so radical 3x over 2x. Again, the x's cancel, and you get radical 3 over 2. And the point of doing this is that every single 30, 60, 90 triangle, no matter what the size is, its sine of 30 will always be 1/2. Its cosine of 30 will always be radical 3 over 2. And you can see the other ones there. 45, 90 would work in a similar way. So here's the ones to memorize, and you don't have to worry right now about what radians means. We'll talk about that later. But the sine, cosine, and tangent of 30, 45, and 60, here's the easiest way to remember this. First of all, you can see everything for sine and cosine, everything is over the number 2, and everything is a radical. Even this 1 right here is really a radical, but radical 1 is just 1, so we don't need to write it. And the way to remember this is the signs count upwards. That's what this says. So we go 1, radical 2, radical 3, and the cosines count backwards, radical 3, radical 2, radical 1. So the sines count up, 1, 2, 3, the cosines count down, 3, 2, 1. Okay, tangent, you can either memorize this one, or you can recognize this. Tangent is actually equal to sine over cosine. And here's why. So if you remember SOHCAHTOA, in SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. If you divide this thing, dividing by that fraction is like multiplying by the reciprocal, so those would cancel. And you get opposite over adjacent, and that's the same thing as what tangent is. So you can just find tangent by dividing sine over cosine. So for example, this is actually equal to 1/2 divided by radical 3 over 2. Those cancel, and you get 1 over radical 3. And if you rationalize that denominator, you would get radical 3 over 3, which is the tangent of 30. This one is easy to remember because in a 45, 45, 90, that's an isosceles triangle. Sine and cosine are equal, so you're dividing rad 2 over 2 divided by itself. Remember, the sines count up, 1, 2, 3, the cosines count down, 3, 2, 1. Those are, I would say, important to memorize because they're used so often. All right, let's use that now to find some of these trig values. So it says use a trig function to find the value of x. Now this is a missing side. In the previous one we were missing angles, now we're missing sides. So this right here, it looks like that one x is adjacent and that's hypotenuse. So if we have adjacent and we have hypotenuse, the question is which of these three would we be using? SOHCAHTOA, well, adjacent over hypotenuse is that one, it's cosine. So we could say this as follows. The cosine of the 30 degrees is the adjacent side x over the hypotenuse 8. Okay. And if we want to solve for x, we can multiply both sides by 8, just like that. And then cosine of 30, let's recall this table real quick. Remember what the cosines and the sines do. Everything goes over 2. And we're just redoing this so you get the practice of seeing this thing. Everything goes over 2. And the sines count up, 1, radical 2, radical 3. Cosines count down, radical 3, radical 2, and 1. So what is the cosine of 30? It's this one right here. It's radical 3 over 2. So let's plug that in. 2 cancels with that, and we get 4 times radical 3. And if you put cosine of 30 in a calculator, you actually get the same thing, just as a decimal. Okay, so they actually do say round to the nearest tenth. So 4 times radical 3, I think that is 6 point. Let's say it's 4 times this number, I think. So what is that? That's like 6.928 or something. So 6.9 roughly. Okay. Let's try one more of these. Let's do the 3b because that's a 4590. We haven't done one of these yet. Okay, so here's the side. This side is opposite and this side is hypotenuse. And you can tell it's the hypotenuse because it's opposite to the 90. So we have opposite and we have hypotenuse. Well, if we remember from SOHCAHTOA, opposite and hypotenuse, that is the same as sine. So this is going to be the sine of 45 equal to opposite is 10, hypotenuse is x. Okay, now here's the problem. We don't have x on the bottom anymore like we did before. So what we need to do is basically do this. We could cross multiply right here. That's a 1. If we cross multiply, we would have 10 times 1 is 10 equals x times sine 45. Now we can divide by sine 45. And in that chart that we talked about before, the sine of 45, let's go back a page. Sine of 45 is radical 2 over 2. Okay, so oops, let me just come up here so we have more room. This is 10 over radical 2 over 2. That's the same as 10 times the reciprocal of that. Okay, and then we're going to get 20 over radical 2, and we can rationalize that denominator right there. So we get 20 radical 2 over 2, and those cancel, and we would get our final answer of 10 radical 2. If you put that in the calculator as a decimal, you would get that right there. Okay, so that is the sine of 45. And by the way, here's a shortcut for this. Instead of doing all this stuff over here, if you had sine 45 equals 10 over x, when the x is on the bottom, you can just swap those. So x turns out to be 10 divided by sine 45, and that's, where is that? That's just what we got right here. So you can just switch those only when x is on the bottom, not when it's on the top. Okay, here are some word problems. This is where we'll include the word problems are obviously the ones that you tend to use the most. So it says to calculate the height of a building, Joe will walk 200 feet from the base and use an inclinometer that kind of measures your eye angle. If his eye level is 6 feet, so he's like 6 feet off the ground here. That's 6 feet. How tall is the building? Okay, so 76 degrees, they're giving us opposite and they're giving us adjacent. So that means tangent, is total means opposite over adjacent. So tangent of 76 is d over 200. We can solve that by multiplying by 200. And then for this, we need to know, that's not one of our special angles, so we actually need a calculator for that. So I'm going to put in 200 times tan 76. This is important. Go to mode. Make sure you are in degree mode, not in radian mode, because we're dealing in degrees. Okay, otherwise, all the answers will come out wrong. So 200 times tan 76, and that is equal to 802.2 feet. So this is 802.2. But remember, he's 6 feet off the ground, so we have to add this extra 6 feet right there. Actually, let's just read that to be sure. We have to add or subtract. I guess they, yeah, we have to add another 6 feet, so this is going to turn out to be 808.2 feet. Oops, okay. Last topic I want to talk about is something called inverse trig functions, and that means that's the symbol for it. So here's an example. Say we said before that the sine of 30 degrees is 1/2. That means the inverse sine of 1/2 is equal to 30 degrees. What that basically means is what angle has a sine of 1/2. That's another way of kind of translating that. Okay, what angle has a sine of 1/2? So this thing right here should output a number, but an inverse sine function should output an angle. Its inverse just means reverse things, go opposite. Okay, so that's what we'll do for some of these. And this is just a bunch of charts showing you basically what I just said. Inverse means tell me what angle has that sine or has that cosine. Let's do a couple of these. So we'll look at this one right here. Find the measure of angle n. So here's n. They're giving us opposite and they're giving us hypotenuse. And opposite and hypotenuse is sine. So the sine of n equals 6 over 10. Okay, we want to cancel out the sine. A lot of people would say you would divide by sine, but remember, sine is not a multiplier, it's something else. It's a function, so you have to do the opposite of taking the sine, which is what we just talked about, taking the inverse sine. Those will cancel. And then whatever we do to one side, we have to do to the other as well, so we will take the inverse sine of the other side as well.